Okay, good morning to all of you. Today we are going to be discuss about Michaelson model experiment to identify the presence of the ether medium surrounding us. So this is the experimental arrangement of the Michaelson model experiment. It is highly sensitive interferometer known as the Michaelson interferometer. That is the schematic diagram of this interferometer. What is the schematic diagram? See, this is the source S. This is one fully polished mirror M1. This is another mirror. Both are perpendicular with each other. If this mirror is like this, then M1 is like this. Both are perpendicular with each other. And G is a half silvered. G. G is another mirror and which is a half silvered mirror, which can be called as the beam splitter. Why it is beam splitter I am going to discuss. Wait. And this is the telescope through which we can view the fringe pattern after interference of the two beams. So what are the two beams is going to be interfere? Let's to be discussed. See, S is the source of the light. This is the source of the light, and G is the half silver glass plate inclined 45 degree to the direction of the light beam from the S. So this G is the half silver glass which is angled 45 degree with the direction of the beam. If the beam is like this angle is 45 degree, so it is inclined with 45 degree with the path of the source light. Okay, the reflected and transmitted beams are to right angle to each other. It therefore act as a beam splitter. So why it is called the beam splitter? G is the beam splitter. It can be split. See, from the source the beam is coming like this. As it is half silver, part of the light is moving this way and part of light is reflected towards M2. So the transmitted light towards M1 and reflected light towards M2 both are perpendicular with each other. So as this G is splitting these two beams, so it is called as beam splitter. Very easy language it is written, no problem. Here M1 and M2 are good quality plane mirrors having high reflectivity. Means whatever the light is coming towards M1 and M2, all the lights are reflected back. We can say like this. Means highly reflectivity. M1 and M2 two mirror has been used perpendicular with each other, and T is your telescope. So what is happening? See, we studied in our plus 2 level that whenever the two rays are or the two waves, suppose this is one wave, this is one wave, and this is another wave. Another wave, suppose like this, having the difference between the two rays are phase difference between the two rays are or path difference will be there. They are going to interfere. They are going to be interfere with each other, and we can found the interference pattern that we have been studied in our plus 2 level your uh, double slit experiment, Young's double slit experiment. And also may you remember, suppose two rays are equal in phase. Suppose one ray having the waveform is like this, another wave having the same waveform but amplitude is different. Suppose this will be another wave having the same phase but different amplitude. So they are going to be interfere constructively, and the amplitude is going to be increased like this. Amplitude is going to be increase if they are out of phase. Suppose phase difference phi will be 180, then they are going to be destructively interfere. That we have been a basic idea we have. So like that, whenever and we also know if phase difference is there, path difference will be there, because your path difference, if I am going to write delta x is the path difference, that is 2 pi by lambda. Sorry, phase difference will be 2 pi by lambda into path difference del phi. These things also we know. So phase difference can be identified if path difference will be present. So if path difference we have, phase difference we can calculate. If phase difference we know, path difference also we can calculate. So here what is happening, that the two reflected ray, one is from M1 coming after reflection, and one is another wave or another light wave which is reflected back from the M2. Both are interfering at G1, sorry G, at here. This ray gone splitted at G and gone towards M1, again reflected back, and another beam is going towards M2 and reflected back, and they are interfering, the two reflected rays are interfering at G and producing the interference patterns due to their path difference. Due to their path difference, obviously phase difference will be created, and due to which we can found the so-called interference patterns. Here the patterns will be like this. Here the patterns will be like this. So what is it is written? See, S, G, M1, M2 are mounted at heavily rigid base. That means S, G both are all are S, G, M1 and M2. These four objects, we can say this is one object, source, glass plate, mirror M1 and M2, both are heavily fixed. They are not going to be moved slightly itself. They are heavily fixed, and only we are going to calculate the path traveled by the light from M1 reflected, and from M2 also reflected, how much they have the path difference. On the base of that we are going to get the phase. So a light beam, what is happening, I'm going to first study and then I'm going to go towards the figure. A light beam from source S enters the beam splitter G and gets splitted into two beams, whatever we discussed, and which will called as reflected and transmitted beam. The reflected beam proceeds towards M2, which reflects it back to G. This beam being partially transmitted through G, produced towards the telescope T, and the transmitted beam from G produced towards the M1, which reflected back to G, is being partially reflected G produced towards proceeds towards telescope T. So if two beams proceeding towards T are slightly out of phase, they interfere, forming the fringe pattern like this. One observes straight line fringes, and the phase difference between the two beams depends on the difference in their time of travel, or the so-called path difference. What it is? That is, one beam is traveling towards M1 and reflected back, again transmitted through G and coming towards T, and another beam is splitted towards M2 and reflected back and again transmitted towards telescope T. Here telescope means one viewer is observing the fringe here. So what it is happening, whenever they are traveling, these two beams, they have some path difference. That means some phase difference will be created, due to which a observer observe fringe pattern. So now we are going to calculate what will be the path difference between these two reflected rays. If we can found the path difference, so easily we can found the phase difference. On the base of that we can found the structure or the variation of the fringe. Okay, so for that we have to first calculate what will the time travel for the path GM1G. That means for the ray which is going from the G to M1 again coming back to G, what will be the time? Then we have to find out from G to M2 to G what will be the time. First we have to calculate GM1G. What is the time travel for the path GM1G? See, for that we have to consider that see, this is your setup. Okay, so here we have been considered that this setup is fixed in your laboratory frame of reference, and this is moving towards the right as earth is moving along the motion of the earth. Suppose this way is earth is moving and this instrument also moving in this way, that we have been considered. So what will happen, see, whenever the light is coming from this source, the speed will be how much, see. So earth is moving this side towards right with the velocity is v. So here we are trying to find out the presence of the ether medium. So if earth is moving this side, and if here a ether or a jelly like structure or a jelly like medium is present around this instrument or around us, a observer is standing over here means around us, that I'm telling. So around us, if a ether medium is present, the ether wind, if earth is moving this side, the ether velocity will be move opposite of that one. Okay, so here we have been considered that earth is moving with the velocity v towards this side. Earth is moving with the velocity v, this is v, towards this side. So obviously ether wind will be travel in this direction, opposite direction with the same velocity. So whenever c or the light is coming out from the source, the speed from after the splitting the g, we can consider the speed of the light with respect to the ether medium will be how much, c minus v, because velocity of earth is same direction and light is also traveling same direction. So whenever the light is travels from g to m1, the speed will be c minus v. And whenever the light is traveling from m1 to g, then the speed of the light with respect to earth, I'm telling about the earth, with respect to earth, it will be c plus v, because earth is moving with the velocity v. So whenever the light is traveling from g to m1, then the velocity of light with respect to earth will be c minus v, because both are the same direction. This is actually alternatively it has been written. You just correct it. Actually whenever moving upstream, that is we can say upstream means moving towards the m1, towards the m1 means it will be c minus v, and from the m1 to g it will be c plus b with respect to earth. Again I am repeating, with respect to earth the velocity of the light will be c minus v whenever it is moving from g to m1. Whenever it is moving, it will be moving from m1 to g, it will be c plus v, because earth is moving, we consider that earth is moving this direction with the velocity v. Same thing it has been written, I am just reading, you just watch. Suppose that entire apparatus is kept in the laboratory in such a way that the path gm1 is parallel to the direction of motion of the earth. Gm1 means this one, gm1 means this one, this one, this ray, this upper ray means upstream, we can say. This gm1 is parallel to the moving of the earth, direction of motion of the earth through the ether medium, through the ether medium. Let net path length be L1. Suppose we have been considered that this path from here to here, the path is L1. The net path is L1 here. This from G to M1 will be L1, small L1. Here it is written. Okay. So net path length be L1 and speed of the light in the ether be c. Then c minus v. Then c minus v is the upstream speed of the light, and c plus b is the downstream speed of the light with respect to the apparatus, or we can say with respect to your earth or the observer, we can say. Okay, because earth is moving with the velocity v towards this side, so the observer will be can be observed the speed of the light with respect to earth will be how much, c minus v. Whenever we are going to consider upstream means g to m1, the observer will be observe the speed of the light when it is moving from M1 to G, that will be C plus V. The path length is L1. This length is steady because G is steady and M1 is steady. So this thing is written that for the downstream it is C plus V. Okay. So now we have to consider the round strip from G to M1 to G. It is moved from G to M1, then M1 to G. What will the total time it has been traveled? So what will the total time see? So we know that velocity v is equal to s by t. So t is equal to s by v. The length is L1 by v for the forward motion. For the upstream, velocity is c minus v. So L1 by c minus v. For backward motion from M1 to G. So G to M1, the time will be L1 by c minus v. From M1 to G, from M1 to G, the speed is c plus v. So what will the time? Time will be L1 by c plus v. So it will be 2 L1 by c by 1 minus v square by c square. It just simplified. Okay. Now we have to find out the time travel for the path Gm to G. The second one, that one's this one, Gm to G. Okay. So let from G to M2 to G, the time has been taken as T2. So what will the value of the T2, that we have to find out. But here I am going to be say to you that, see, whenever the earth is moving in this way, the light is traveling from here to here. In that time, this M1 is just shifted to here. Apparent shifting of M1 to M2 to M2 dash position. This. So what will be the distance? It will travel from here to here with this time t. This distance will be v into t2. V into t2. Suppose we have been considered, it is written that t2 dash. Suppose t2 dash. Suppose from G to M2 it is traveled and the time taken is t2 dash. That t2 dash will be how much? How much it will be t2 dash? It will be v into, okay, suppose from G to M2, when it is traveling towards G to M2, as Earth is traveling this side, let this M1 is apparently shifted to, M2 is apparently shifted to M2 dash, have a distance, suppose this distance is d, suppose this distance is d. So what will be this d distance? This d will be v into t, v into t2 dash. Okay, v into t2 dash. Again, from here it is going to be reflected apparently here, from here it will be reflected back with again t2 dash time. So what will the total time that we are going to be calculate over here? See, here it is clearly it has been mentioned in this figure. You can see, let's see, from G to M2, when the light is traveling, as Earth is moving towards this direction, so the M2 mirror just shifted to M2 dash position. M2 dash position. Let this distance is your d. What will the distance this can be? This will be v into t2 dash. Okay. So these things it has been, while the path of the reflected beam traveling from G to M2 and back to G is a cross stream path through the ether. While the beam going from G to M2, the mirror M2 moved to right relative to ether through a distance d v2 dash, what we discussed, to the position M2 dash new position. This is the apparent position because due to the presence of ether medium to the position M2 dash. At the same time, the light travels a distance c t2 dash. You got my point? See, when the light is traveling towards this, as Earth is moving towards this light is not going to be incident directly at the position M2, because due to the presence of ether medium, we can say that M2 is relatively shifted to the new position M2 dash. So what will the path? The path will be this one, GM2 dash, due to the presence of ether medium. So what will be this path? This path will be CT2 dash, not L2. This will be CT2 dash. So what will the value of T2 dash? It will be, if it will be right angle triangle, then T2 dash square will be L2 dash square plus V T2 dash square. Okay. If time has been taken to reach from G to M2, at the meantime M2 is shifted to M2 dash. The path will be not from G to M2. The path will be G to M2 dash. That will be C2 dash. That C2 dash path can be calculated by using right angle triangle. This will be C2 dash square will be equal to L2 square plus V T2 dash square. That will be C square minus V square T2 dash square will be equal to L2 square. Just you take this towards to the left side, this equation we found. Hence that implies T2 dash will be equal to L2 by C, just simplified, divided by 1 minus V square C square root over. Okay. Now the time taken for the round trip is also T2 dash. If T2 dash is taken from G to M2, traveling the path, this much path, it is taken as T2 dash. Again coming back from M2 to G, also same time it will be take T2 dash. The total time will be 2 T2 dash. Hence the time for a return trip is also T2 dash. Hence time travel for the round trip will be how much? T2 will be equal to 2 T2 dash will be equal to 2 L2 by C, 2 L2 by C by 1 minus V square C square root over. Okay. Now we are going to find out the time difference between the two rays coming back. One is from coming back, going moving from G to M2 and again coming back to this position, and another light which is reflected from G coming towards M2 and coming back to G. What will the time difference? From that we can calculate the path difference and phase difference. So what will the time difference? Del T will be equal to T2 minus T1. T2 will be this much minus T1, we found this one, 2 L1C by 1 minus V square C square. Okay. So now you just subtract it and we can found is it will be this much, right? So if this will be the time difference we found, then the path difference will be C into T, because V is equal to S by T. So del S will be V is the nothing but the speed of the light into time. So this will be C into del T, C into T2 minus T1. If this will be your path difference, this C del T is your path difference, then what will the phase difference? Phase difference will be delta will be 2 pi by lambda into path difference. This is 2 pi by lambda. Path difference is C into T2 minus T1. So this will be 2 pi by lambda, and C into T2 minus T1 value we found is this much. We have to substitute over here. This will be is nothing but is your phase difference between the two beams which are interfering at G and producing the interference pattern. Okay. So for this class up to this much. Next class we have to proceed if we have fringe shift due to 90-degree rotation of the interferometer. The interferometer is like this. If I will rotate this interferometer like this 90 degree, that means like this, then what can be fringe will be produced. So here due to the phase difference we found the fringe. So, and also in the next class we are going to discuss due to the ether medium how the fringe is going to be fringe pattern can be changed, and presence of ether is going to be confirmed or not, that we are going to discuss in our next class. So up to this much you have to go through this video and write down the note. Thank you so much.